Good morning. Morning. Good morning.
Morning.
Okay, good. So we begin with the discussion on functions. It's a very wide chapter, but we'll discuss a few the main things on functions, but a lot of things you can actually read on your own. But we'll start you off. So we begin by defining a function and then discussing different types of functions, and then see how we can transit into concept of limits, continuity, and differentiation. So encourage others to join so that we can start. So let's give the definition of a function. So let A and B be two sets. So a function f from A to B denoted by so this is how we denote it. So a function f from set A to set B is a rule that assigns a unique element f of x in B to each element x in A. And unique means a single element. So a rule that assigns a unique or single element f of x in B to each element x in A is called a function. So when we write, we read this as f of x. So we write f, we put x in bracket, then it's read as f of x, not f into brackets x. So that means f of x, which simply means function which depends on X, or a rule that assigns a unique element f of X in set B to each element in A. And this is how we write it. So here, A is called the domain of F while B is called the codomain of F. The set of all outputs of f of X as X varies is called the range. So we use to denote domain of F and we write to mean range of F. So those are the abbreviations we use for domain and range of the function. And maybe pictorially we can draw this to, if I have one circle here, let this be set A. Let this be set A. And let's have here a set B. Let's have some points in this set A. And then we have other points in set B. So let this say be x1, this be x2, this be x3, this be x4. So if x1 is taken to this point, a rule that takes x2 to that point, say a rule that takes x3 to that point, and let's say that the same rule takes x4 to that point in B, so that this becomes f of x1, f of x2, f of x3, f of x4. So this is f. So such an assignment that takes elements from A to set B is what we are calling a function from set A to set B. So A is what we call the domain, and then B is what we call the codomain. And so inside the codomain, the values of the function. So this values of the function after it takes points from set A is what we call range of the function f. So range is a subset of the codomain. So finding domain and range. So I'll demonstrate this with examples. So find the domain and range of the following functions. So the first one, f of x equals to 2x plus 3. Second one, f of x equals to x squared. Next one, f of x equals to 1 over x. Next one, f of x equals to square root of x. Next one, f of x equals to x squared minus 4. Next one, f of x equals to x squared minus 4, square root of x squared minus 4. And then g, f of x equals to square root of 4 minus x squared. H, f of x equals to 1 over x plus 3. I think these are enough to make us master the concept.
Ndio maana nimeshangaa. Ndio hiyo.
So then now, please note that domain and range of functions we discuss will be assumed to be are taken as subsets of real numbers. So the possible largest subset of the real numbers is what will help us to define the domain and the range of a function. And in so doing, you ensure that you don't leave out any number that qualifies to be within the domain and within the range of the function you have. And so in simple terms, domain from a layman point of view will simply means set of all possible inputs, while range will mean a set of all possible outputs. So domain means all the possible values of x that when you put in the expression that define the function, do not give you a math error if you are doing using a calculator, that any value you say that is in the domain of the function means that that x, when you replace it in the expression for the function, you get a number, not undefined expressions. And the range is now the set of all those possible numbers that you find after inputting the domain values. So we have our first function as f of x equals to 2x plus 3. So what we normally do, we get some real numbers, say negative numbers, and say 0 and some positive numbers, and replace for x and see whether the expression 2x plus 3 will give us another number, another real number. For example, if I was to pick, say, minus, say, 10 for x, but there's nothing special with minus 10, you can pick any other negative number. What will be the value of 2x plus 3? If you are to replace x for 10, what will be x for minus 10? What will be the value of f of x? What will be the value of the function? Where is x if I put minus 10?
Negative 17.
Negative 17. Negative 17 is a real number, correct. If I put 0 for x, what will be the value of 2x plus 3? 3. So 3 is still a real number. And if I pick a positive number, say even say 10, positive 10, 2x will be 2x plus 3 will give us which value?
23.
23. So 23 is a real number. And you should actually check that any random arbitrary negative number you pick, you replace for x, it will give you another number after saying 2 times that number plus 3. When you put 0 for x, you will also get another number. If you put any positive number for x, you still get another number. So therefore, we say the domain of this function is actually the set of all real numbers. So the domain of f is set of all real numbers. Hello? Hello? I'm sorry, Sandra. Sorry. So we say that the domain is a set of all real numbers, or you can just simply write R. Or you say, there are many ways of actually putting your answer. You can either write R, or you can just put in what set of all real numbers, or you can write the set in terms of the interval from -infinity to +infinity. So different versions, but just stick to one. Or you can write from -infinity to +infinity. So this is the domain. Or you can write set of all real numbers. You need not to write all these different things. So just stick to one. If you just write either using a notation, or you write this interval notation, or put in words, still okay. Then f of x equals to x. So then once you have this, the domain, now what is the range? So when you put in those numbers, you pick all the real numbers and you fix for x. What kind of numbers do you generate after saying 2 times the numbers you are replacing plus 3? So is it possible to get negative numbers after you have put real numbers in 2x plus 3? Is it possible to get negative real numbers?
No.
For the expression 2x plus 3?
No.
Remember, we have said domain. We have said domain is a set of all inputs. And we are saying that for this function, the inputs are going to be real numbers. Remember, real numbers, there's negative, there are zeros, there's zero, there's positive numbers. So once you pick these real numbers and you put in the expression 2x plus 3, where there's x, is it possible that the answers you get, some of those numbers will be negative?
Yes.
Yes.
Is it possible to get 0?
No.
For 2x
Yes.
plus 3, which value of x gives
Yes.
0?
0.
When x is? When x is?
It is not possible.
1. Negative 1.
Okay, so remember, this is simply what I'm asking. So we have 2x plus 3. So when is this 0? What's the value of x?
Negative
It can't be
1.5.
zero.
Negative 1.5 or negative 3 over 2. So when you x and negative 3 over 2 is another real number. So it's possible to get 0. And then is it possible to get, once you have taken, are there some real numbers which will give positive values for 2x plus 3?
Yes.
Yeah, so you get them. And you realize that all the positive real numbers are possible once you fix real numbers for the place of x. You can also get 0. You can also get negative real numbers. So therefore, the range of this function f of x equals to 2x plus 3 is the same set of all real numbers, or you can put in interval notation, or you can just write R. So f of x equals to 2x plus 3, the range and the domain is the same, and is a set of all real numbers. Let's go to function B. F of x equals to x squared. f of x equals to x squared. So what possible inputs for x will produce other numbers? Or if in simple terms, which values of x, when you replace here and you use your calculator, do not give you math error. So things which will not give you math error when you compute are numbers which form part of the domain. So let's say if you put negative numbers, like say negative 10, and then you say, what is negative 10 squared? What is negative 10 squared?
100.
100, positive 100. And then when you use 0, what is 0 squared?
0.
0. And then say, let's take positive. Say, for example, 10. What is 10 squared?
100.
100. So then now, and you should check that there's nothing special with 10 that I'm picking. If you pick any positive real number, when you put in the place of x and you square, then it will give you another number. And you do not give your math error in your calculator. Similarly, when you put 0 for x, when you square, you'll also get another number, which is 0. And also when you pick any arbitrary negative real number, you put for x, and then you compute using your calculator also, you'll also get a value. You'll not get a math error. So therefore, we say domain for this function b is a set of all real numbers. So domain is a set of all real numbers. So we can just write the way we have written in the case A, R, or you write this in interval notation, or you write in words, set of all real numbers. So now, once you get the inputs, once you have the inputs now, you can, let's see how they are behaving. They are saying that, for example, if you pick x for negative 10, so negative 10 is just one example of a negative number, but you can pick any negative number that you wish to have. So if I have minus 10, then the value of x squared would give me 100. If I have 0, then I'll have 0 squared equals to 0. And if I have a positive number, for example, say positive 10, when I square, I get 100. So what can we say in general, how the expression x squared is behaving? How is the expression behaving? X squared, as we take real numbers and we square. How are the values behaving, or what are the trends? You can pick any other negative numbers, pick any other positive number. There's nothing special with 10. And then just put in the expression and then square them and tell me how are they behaving in general. Or what is it not possible? Which numbers are not possible for the expression square x squared?
Negative numbers.
Negative numbers are not possible. The least number that we can get after squaring is? The least that we can get after squaring? 0. Correct.
0.
And anything more than 0. So then the range for this function f of x equals to x squared will not just be all real numbers, will be set of all those non-negative real numbers. So we say range in B, the set of all non-negative real numbers. Please note that non-negative is not the same as positive. So when you say positive, you'll be eliminating 0, which is not true. So the key term is non-negative real numbers, or you can put in interval notation as from 0 to infinity. and this is a square bracket to show that 0 is part of the set. So the range of the function f of x equals to x squared is a set of all those real numbers from 0 inclusive to infinity. So it's not possible to get negative numbers after squaring any real number. Then f of x equals to 1 over x. So take negative numbers, take 0, then take say positive numbers and see, do they give a result or there are some which will not work? Are all the real numbers working, as we have said in the case 1 and case 2, or there are some which will not work? Make use of your calculator. Pick arbitrary negative numbers, pick positive numbers, and then 0. And see which are all of them working or some will not work.
Some will not work.
Like which ones?
0.
0. Apart from 0, is there any other number that will not work?
That's the one.
That's the only one, yes. So 0 is the only one. So that because it will be now giving the expression 1 over 0. So when x is 0, so we'll have 1 over 0, this undefined. So therefore, here we say the range, the domain of f of x in C is the set of all real numbers except 0. 0 is the only real number that doesn't work, but all the negative real numbers and positive real numbers will not give a math error. So domain of f in C is set of all non-zero real numbers. Or if you don't want to write this, you can just say from minus infinity to 0, union 0 to infinity. And use this kind of brackets to show that 0 is not part of the set. So if this is a real number, where you have this is minus infinity, this is positive infinity, and here is where you have 0, then any number on this line except the numbers at except this number 0 will actually form part of the domain. So you pick this part plus this other part is what you're saying from minus infinity to 0 union, or we are joining to 0 to infinity. And these are the kind of brackets we use, curved brackets, to show that the end point number is not part of the set. So all non-zero real numbers will form the domain of F. Now, once you have selected all those real numbers except 0, and you put where there's X, how does the final answers look like? Or what are the general trend? What is the general trend of the result? Is it possible to get negative numbers after removing 0 from the set of real numbers and putting for X, the expression 1 over X? Is it possible to get negative real numbers? Remember, all real numbers, we discussed about types of numbers and real numbers when we are doing sets, so you should not have trouble. Is it possible to have a negative number when X is picked from this set we are saying all non-zero real numbers?
Yes.
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 Yeah, have negative numbers are possible. Then is it possible to get positive numbers as the final expression, as the final answer for 1 over x, where x is picked from non-zero real numbers?
Yes.
Yes.
It's also possible. Is it possible to get 0? Is there a value of x from this domain that will give us 1 over x to be equals to 0?
No.
No.
There's no value of x that will make 1 over x to be 0, because actually, if assuming this was an equation to solve, then we say 1 over x equals to 0, then you cross multiply. So we'll have 1 equals to x times 0 is 0, which is an absurdity. 1 cannot be the same as 0. So therefore, negative numbers are possible, positive numbers are possible, but the only impossibility for 1 over x as the final value is to have a 0 as the answer. So the range is the same set of all non-zero real numbers, or you can just write from minus infinity to 0, union 0 to infinity. Then let's go to the next one. F of x is root x. So let's say the domain. I remember we start by random search or random test. Pick negative real numbers, pick 0, and then say pick positive real numbers and see which ones work, which ones don't work.
All non-negative numbers.
All non-negative numbers. So negative numbers will not work, because when you put negative number there, then you put, for example, square root of -1 in your calculator to give you math error. So the domain will be set of all non-negative. Non-negative means not negative. Non-negative real numbers. If you say set of all positive real numbers, then you get it wrong, because you'll be excluding 0, which is not true. If you key in square root of 0 in your calculator, it will give you a number which is 0. Or you can just write in interval notation, you will have curved bracket 0, then to infinity. This to mean that 0 is part of the set. Good. And now once you have excluded negative real numbers, what kind of numbers does your screen display? What you are seeing in your calculator after putting 0 and other positive real numbers? What is the trend of the numbers you see on your screen as your final answer for square root of non-negative real numbers? How do those numbers behave after putting 0 and other positive real numbers, and you define the square root? What are the final answers on the screen of your calculator? How do they behave?
A set of all non-negative real numbers.
Correct. It's exactly the same set. So the range of f of x, which is square root of x, is a set of all non-negative real numbers, or you can just give in this interval notation. So put curved bracket 0, then to infinity. Good. Now let's see the next one. F of x is given by x squared minus 4. So the first thing is domain, which is a set of all the possible inputs. So x is a place where we are going to input to test for some arbitrary real numbers. So take some negative real numbers, take 0, and then take positive real numbers. and see what the trend of the expression, which numbers work and which numbers don't work. Like when you have negative numbers, does the expression x squared minus 4 give you a number or it give you a math error on your calculator? If you have negative values of x, then you square them and then you subtract 4. Do you get a number or you get a math error?
A number.
A
It's a
number.
number. So if you get a number, then all the negative numbers work. Then when you put 0 for x and you square then minus 4, you get a number.
Yes.
Number.
So you get a number. So 0 also work. When you pick positive values of x and you put where there's x and square and minus 4, does the final answer give you a value or it's a math error?
A value.
It's a value. So then what is the domain?
Set of all real numbers.
Correct. So domain is the set of all real numbers. Good. Any value of x you put here, the expression x squared minus 4 will be defined. Now, range. So now you have now to say what is the pattern. As you put negative real numbers, as you put 0, as you put positive real numbers, what is the overall trend on how the expression x squared minus 4 behave? Like let's say, we say that when we put 0, when x equals to 0, then f of 0 will be?
-4.
-4, because we are simply where this x is where you're putting 0. Say when x is say 1, f of x will be?
-3.
-3. When say x equals to 2, f of 2 will be?
0.
0. When x say is 3, what is f of 3?
-5.
5.
Positive
5 or negative 5?
5.
Positive
5. Positive.
And
Yeah.
when x is 4, what is f of 4?
12.
12. Say when x is 5,
12.
what is f of 5?
21.
21.
Okay?
21.
21. Can you predict what is happening? So when x is 6, even before we getting the answer, what do you expect to have? Is it a number less than or more than 21?
More than
It's more than 21.
More than 21.
So the values are actually increasing, okay?
Yeah.
And let's see.
Yes.
If you were to pick, say, negative x equals to -1, then what is the value of f of -1?
-3.
-3. When x is say -2, f of -2?
0.
0. When x is -3?
5.
5. When x is -4, say, then f of -4 will be?
12.
12. So we can actually see that the trend is also same as what is happening here. Values are also increasing, okay?
Yes.
So is it possible to get a value less than -4? Any x from the domain we have stated? Is there a real number which,
No.
when you replace for x, it will give us a number or a value less than -4?
No.
Or when do we have smallest value for f of x? Is when x is
0.
When x
0.
x 0.
When x is 0 is when you'll have the smallest one. But when you have any other non-zero value, then this expression will be having more value. So then what can we say about the range now?
-4,
2
To infinity.
Yes. So range will be -4 to infinity. That the smallest value of this expression, x squared minus 4, when the values of x are picked from the set of real numbers, is going to be -4. And it will happen when x is 0, but any other non-zero value will always be making this expression grow bigger and bigger. As the values increases both from positive side and negative side, the expression gets larger, larger, and larger. So therefore, the range will be from -4 to infinity. So check that now, if now we reverse to 4 minus x squared, then our domain will be the same as set of real numbers the way we have, but then the range of f will now be from -infinity to -4 to +4. I don't know if you can see that. Are you able to visualize that from the previous workings? That when f of x is defined as f4 minus x squared, then the range will be from -infinity to 4. And it will be at 4 when x is
Zero.
0. But you can
0.
actually see that when, for example, when you let x to be 1, I'll have 4 minus 1, which is 3, less than 4. If you take any other non-zero value and you put for x, whether negative or positive, the surest value to get will be a number less than 4. So the maximum that f of x, which is 4 minus x squared, can give you is 4, and all numbers below 4. Good. And then the other question is square root. Square root of x squared minus 4. So please, these are some of the key highlights that can help you to deal with such kind of problems. From our previous problem of square root of x, we have said that for square root functions, so when you say square root functions, I mean there will be functions which have a square root sign. The expression under the root sign must always, what are the condition for number inside the root sign? For that to be defined, the number under the root sign must always be
Non-negative.
non-negative, correct. Must always be non-negative. And remember, the meaning of non-negative means it should be greater than or equals to 0. So that's the interpretation. So whenever you see a square root function, then know that the condition is that what is under the root sign must be greater than or equals to 0. So you will say for this thing to be defined, x squared minus 4 must be greater than or equals to 0. And then this means x squared must be greater than or equals to 4. So if I assume equality, x should be, which values of x satisfy the equal sign? What should we replace for x so that when you say x squared, the answer gives us 4?
2.
2. 2 is the only number that will satisfy that. Don't disappoint your high school maths teacher. Which values of
-2.
x?
Negative
2 and
two.
-2, both of them satisfy that condition, okay? Yeah. So having those two numbers, you draw a real line. So where we have -2, we have 2, and this is going to be positive infinity, is going to be minus infinity. And so now we want to reason and see which interval satisfy the condition that the expression x squared minus 4 should be greater than or equals to 0. So remember, there are 3 subintervals after having those two numbers, 2 and -2, splitting the real line. So there's this interval A, there's this interval B, there's this interval C. So where interval A is from minus infinity to -2, B is from -2 to 2, and C is from 2 to infinity. So to know which of those 3 subintervals satisfy the domain or the condition x squared minus 4 greater than or equals to 0, pick any random number between minus infinity and -2. Give me any number in that interval. Any number from minus infinity to -2?
-1.
Sure. Can -1 be found from minus infinity to -2?
-7.
Say -7, correct. So
Oh,
where does x, put -7 and see whether it satisfies that condition. So -7 squared minus 4, is it a number more than 0?
Yes.
Yeah. So if that's the case, then it means that all the numbers within that interval work. And there's nothing special with -7. If you pick any other number apart from -7, provided it's between minus infinity and -2, it will have the same interpretation. Then if I put -2 itself where there's x, will it satisfy the condition greater than or equals to 0? If I want to check at the boundary now, if I put where there's x by -2, if I square that and I subtract 4, does it satisfy this condition?
Yes.
It's also satisfied because it will be 0 equals to 0 is true. So all even at -2 is part of the domain. Good. Then can you pick any number from -2 to 2? Pick any number from -2 to 2.
1.
1 is okay. But the easiest one actually, why can't you just pick the boundary, which is the mediator 0? So, okay, also 1 is okay. 1 squared minus 4, is it greater than 0?
Yes.
Yes.
No.
Is it greater than 0? 1 squared minus 4.
No.
No.
As even if you say, if I pick this 0, 0 squared minus 4 is still not more than 4. So then B does not work. So all numbers from -2 to 2 do not satisfy the condition x squared minus 4 greater than or equals to 0. So no number in that interval should actually be part of the domain. Now the 2 itself, does it work or it doesn't work? The endpoint 2.
It works.
It works because 2 squared minus 4 is actually 0, and 0 is greater than or equals to 0 is true. So 2 is also part of the domain. And then pick any number from 2 to infinity. Any
5.
number from 2 to infinity. Say 5. 5 squared minus 4. Is it greater than 0?
Yes.
Yes. So this number, this interval also works. So therefore you say the domain will be the interval from minus infinity to -2. And I use square bracket because that -2 is part of the domain. Joined to means union 2 to infinity. So that's how we define the domain. So that the domain of the function square root of x squared minus 4. Now range. Remember we are dealing with f of x equals to the square root of x squared minus 4. So then range means now, once we have identified this our domain, when you pick numbers in this interval or this interval and we fix for x, and then define their square root, how do those numbers behave on the calculator? So like when you pick, say 10 for x, or say, so they, what is the smallest value for x squared minus 4? Is when x is?
0.
We need x, this thing should be 0. So 0 when x is minus 2 or positive 2. Then when you pick, say, x for 10 to be 10 squared minus 4, then square root. And then do repeatedly and tell me what is the trend? How is the expression square root of x squared minus 4 behaving?
Set of all non-negative numbers.
So we'll have range. I remember not just numbers, but real numbers, be specific. So range will be this set, 0 to infinity. Then the other one was the square root of 4 minus x squared. Minus x squared. This is still a square root function, and the condition is that 4 minus x squared should be greater than or equals to 0. That the number under the root sign should be non-negative for the root to be defined. So this means 4 should be greater than or equals to x squared. So which x values satisfy the equality? What x values satisfy x squared being less than or equals to 4?
Plus or minus 2.
Plus or minus 2, correct. Now, once you get those two numbers, you use them to split the real line. So this positive infinity, this negative infinity, and then have a minus 2 here, then have a 2 here. So we'll also have 3 subintervals. A, B, and C. And we do the same thing that we have done in the previous case, that the condition in this problem now is that 4 minus x squared must always be greater than or equals to 0. So pick any number from minus infinity to minus 2.
Minus 3.
Digit minus 3. So what is 4 minus 3 squared?
Minus 5.
Minus 5. So is minus 5 more than 0?
No.
No. So therefore, these don't form part of our domain. Does 2 minus 2 itself work?
Yes.
Yeah, so minus 2 itself works. So minus 2 will be part of the domain. And then maybe let's just test the extreme points. 2 itself, does it work?
Yes.
2 works. And then can you pick any number from minus 2 to 2?
0.
0 is the easiest. Okay, there are more numbers, but 0 is the easiest one. It's very easy to deal with 0. Actually, start separating minus 2 and 2. One on the left, one on the right. So when you put 0 for x, is 4 minus 0 squared greater than 0?
Yes.
Yes.
Yeah, it's greater than 0. So that means that this interval works. And there's nothing special with 0. Pick any number from minus 2 to 2. It will give the same interpretation. And then pick any number from 2 to infinity.
6.
Say 6. So what is 4 minus 6 squared?
Negative
It's positive.
32.
Negative. So negative, and we expect it to be positive. So numbers in this interval don't work. So therefore, we say the domain for this function will just be from -2 to +2. This will be the only numbers or the values of x that will make the expression under the root sign to be defined. And then what will be the range now? Once you have said that you are restricting yourself to just from -2 to 2. So what do you expect to have your final answer for the square root of 4 minus x squared?
Set of all negative real numbers.
So you say from 0 to infinity. So say according to that statement is you are saying that you imply that the range will be from 0 to infinity. True or false? As per your explanation. So is it true that the range is from 0 to infinity?
No.
Okay, so what is the smallest value of what should be the smallest number under the root sign for us to define its square root?
0.
0, okay? And when do you attain that 0? When the value of x is?
Positive or negative?
Negative, positive or negative 2. Then, and remember we are saying that we are restricting ourselves to numbers from -2 to 2. So what makes you, which value from that interval will give x minus 4 minus x squared as a bigger number? What should we set for x for us to get a bigger value of 4 minus x squared? What should be the value of x in that interval to get a bigger value for 4 minus x squared?
0.
0. So when x is 0 is when we have a bigger difference of 4 minus x squared. So when now square root of 4 from your calculator, what are you saying? What does your calculator display when you say root 4? Which
2.
number do you see on the screen?
2.
2. So therefore the range will be from 0 to? So the range will be now from 0 to 2. So once our domain is from -2 to 2. So you can see the difference between square root of 4 minus x squared and square root of x squared minus 4. So the way we interpret the domain and range is totally different. The first condition is that number under square root sign should be non-negative. And then you get those two numbers, use them to split the number line, and then test in each of the sub-interval to see which interval work and which one doesn't work. They do not. Then 1 over x plus 3. Now from your high school and primary work, this actually is an example of what we call reciprocal functions or fractional fraction. This comes out like a fraction. So which condition do you impose on a fraction for it to be defined? If someone gives you a over b, which condition must you always impose for that thing to be defined in all cases?
B must always be greater than A.
Okay, there's no problem. There's no problem. This is still a fraction. There's no problem. So that's really not necessary. So just now to give a different name, proper and improper fractions, but there's no problem with that. What is the key thing for the fraction to be defined? Key thing for the fraction to be defined? Don't disappoint your high school math teacher. Can we have like 12 over 0? Can we have a fraction like 12 over 0?
No.
So the condition is that for fractional or say rational functions, denominator must be always non-zero. That's what you test for. Some expressions which takes the structure of a fraction, that what is in the denominator must always be non-zero for that fraction to be defined. So here then, the domain will be simply take denominator and say that for it to be defined, it must be non-zero. So what does that one tell you about x? What does that one tell you about x? If x plus 3 is not equals to 0, so what do we mean? What do we mean by x? Which values of x should be taken? Should be not equals to
-3.
-3, correct.
Yes.
So therefore, domain is set of all real numbers except x equals to 3 minus 3. Or you can write this one as from minus infinity to minus 3 not included, union minus 3 to positive infinity. Now range. Remember we have 1 over x plus 3. Is it possible for this thing to give us a 0? Is there a value of x that can give 1 over x plus 3 to be 0?
No.
So if it's like if I was to equate this one to 0, then I mean 1 equals to 0, which is an absurdity. So for this fraction, it is not possible to, there is no value of x which will reduce the fraction to 0. So therefore range will be all non-zero real numbers. All non-zero real numbers will be the range of that given function, or you can write this one as minus infinity to 0, union 0 to infinity. That's how we explain the domain and range. I want to give you time so that now you go through and do as many examples on range and domain. So the next time now we discuss different types of functions. To give you time and digest what we have done on domain and range. Or do you have some stamina for us to continue? Can we briefly introduce concept of different types of functions?
No.
No.
No,
Or we can
No,
give you
no.
time to go through domain and range?
Yes.
another day.
Another day. Another day.
Okay, fine.
Yeah.
So let's stop there. So next time we meet, so probably tomorrow. We'll be discussing about different types of functions. So have a good day.
Bye.
Yeah.
Okay.
Bye.
Okay.
Bye.
Bye.
Tumakai.